Have you ever stopped to think about how cloud storage, something like Amazon S3, can actually be faster than the hard drive that's literally sitting inside your own computer? It seems impossible, right? Well, today, we're going to pull back the curtain on the architectural magic that makes this happen. We're going to see how services you use every single day achieve that incredible speed and reliability. Okay, so let's start with a puzzle. Imagine a brand new hit movie drops on a streaming service. How is it possible that 10,000, or heck, even 10 million people can all start streaming that one 4K movie file at the exact same instant, and nobody's screen starts buffering?
I mean, if you tried to do this with just a single computer, it would be a complete and utter disaster. A normal hard drive has a physical speed limit, right? It can only read data so fast, maybe 100 megabytes per second if you're lucky. Under the strain of thousands of simultaneous requests, the little disk head would just thrash itself back and forth, performance would totally crater, and the whole system would grind to a miserable halt.
This right here has a name. It's a classic engineering challenge, and they call it the hot disk problem. It's what happens when one piece of data becomes so popular, so hot, that the single physical device it's stored on becomes the bottleneck for the entire system. It's the core problem that S3 was basically born to solve.
So how did they solve it? How did they crack this nut? Well, the secret is all based on one big, clever lie. A fundamental misunderstanding that most of us have about how cloud storage actually works. And it's a really simple premise, but it changes absolutely everything. Here it is. When you upload a file to S3, you probably picture it sitting neatly in a folder on some server somewhere, but that's not what happens at all. The truth is, your file, as a single, complete thing, doesn't exist in one place on their servers, and that's the key to everything.
See, this whole strategy of not keeping your file in one place, it's genius because it solves two massive problems at the exact same time. First, you've got blast radius management, which is a fancy way of saying making sure your data can survive a total catastrophe. And second, you have heat management, spreading out all the requests for that popular file so no single server just melts down. So let's start with how they protect your data.
Okay, let's dig into this first strategy. It's all about building a digital fortress to make sure your data is pretty much impossible to lose. Now, when you save a file to an AWS region, you're not saving it to some single monolithic building. A region is actually a collection of multiple physically separate data centers. They call them availability zones. And when I say separate, I mean it. We're talking buildings that are miles apart on totally different power grids, even located on different floodplains. They are completely isolated from each other.
So when you upload a file, S3 doesn't just save it once. Oh no, it writes copies of that file to disks in at least 3 different availability zones. And here's the crucial part. It only sends back that success message to you after it has confirmed that all of those copies are safely stored. This means a fire, a flood, a power outage in one data center has zero effect on the others.
This is how S3 gets to its legendary 11 nines of durability. That number looks kind of absurd, but what it actually means is that if you stored, say, 10 million files, you could expect to lose maybe one of them every 10,000 years. Yeah, your data is ridiculously, incredibly safe. But look, durability is only half the battle, right? Now let's get to the really cool part. The second and honestly more fascinating strategy. This is how S3 delivers that mind-bending speed. You can think of it like a swarm. So S3 doesn't just make copies of your file, it literally shatters it into pieces. A 5 gigabyte movie file isn't stored as one big clumsy block. Instead, S3 breaks it up into hundreds of tiny chunks, and then scatters those chunks all over a huge number of hard drives. This whole process is called sharding, and it's a total game changer.
So why on earth would they do this? Well, it all comes down to basic physics. Reading a 5 gigabyte file from a single disk chugging along at 100 megabytes per second, that's going to take you almost a minute. But what if you could read from 50 different disks all at the same time? Bam! You get a combined speed of 5,000 megabytes per second, and you can download that entire file in just 1 second. It completely decouples the file's performance from the physical limits of any single piece of hardware.
So here's a simple little example of how it all clicks together. Let's say we have a 1 gig file split into 4 chunks. Now notice how those chunks are stored not just on different devices, but they're also in different availability zones. This one brilliant design choice delivers both things at once. You get that blistering speed from reading in parallel, and you get that ironclad durability because the pieces are spread out all over the place. Okay, so let's tie this all together and bring it right back to our original question, why your favorite show just starts with no waiting around.
The absolute genius of S3 is that it found a way to cheat the physical limits of a single hard drive. By shattering files and spreading them across this massive fleet of servers, it allows for massively parallel access, which gives you incredible speed. And by spreading those same pieces across different data centers, it guarantees your data is always safe. And that is why your movie streams perfectly, even when 10,000 other people are hitting play at the exact same moment.
Which, of course, leaves us with one final, pretty mind-bending question, doesn't it? We know the file is in hundreds of little pieces scattered across this vast infrastructure. So how in the world does S3 find all of those pieces and stitch them back together in the right order in just milliseconds without you ever noticing a thing? Well, that's a whole other story for another explanation.